Hello, everybody, and welcome. No matter where you are in the world and what time of the day it is, we appreciate your being present with us today to learn more about automotive hazards and how we can overcome some of those hazards. As Fernand said, I'm Dan Miller. I am from Nebraska in the United States. I've been an encapsulator specialist and manufacturer's rep for hazard control technologies for 2 years as of October 1st. And my background includes degrees in electronics with 35 years in automotive electrical experience, 40 plus years of fire service experience as a firefighter, hazmat technician, EMT, fire chief, and instructor for many years. Worked in very small volunteer rural departments all the way up through metropolitan class cities. So big fan of automotive industry, motorsports, racing, been around cars all my life. And I'm always intrigued about the technology advancements in the automotive industry. I think it's really neat stuff that we've got going on now, but it's also raising some new issues that we have to deal with. So one of the big concerns we're dealing with, of course, is lithium-ion batteries. But today we're going to talk about the whole array of automotive hazards, not just focus on lithium-ion batteries, although we do have a segment on that. And our agent does very well with that. We're going to talk about all automotive hazards and how hazard control technologies can help you overcome some of those hazards. So we've got about 5 different sections to go through here, and in order to keep it moving for everybody, we'll get started. If you do have questions, be sure to put them in chat so that we can address them at the end one by one. And we want to know more about you as well, because we want to know what your role is. If you're here as public safety, as a firefighter, or if you're from the automotive industry, or if you're from a different industry, we want to know what your role is and what your biggest concern is. What prompted you to join our webinar today? So, and our ultimate goal is for you to have us, for us to have you get a hold of us so that we can talk to you one-on-one and answer your concerns. So first thing we're going to do is talk about some of the hazards that are on the rise within the automotive industry. Automotive fire hazards are getting more and more complex as technology advances and engineering changes to meet market forces. There's a lot of new materials involved in automotive engineering. There's a lot of new construction techniques in automotive engineering, and a lot of new manufacturing and processing techniques, all the way from when automobiles are initially created from the originating materials all the way through the recycling process. So, and that's pushed by global initiatives, and those global initiatives push things like the development of hybrid and electric vehicles, and that's growing rapidly with no end in sight. I recently saw a graphic on LinkedIn where there was from the year 1900 in New York City, and it was nothing but horses and buggies. And there was one car on the street. And 13 years later, in 1913, picture of the same street, there was one horse and buggy and all cars. So EV cars will come rapidly. They're continuing to grow, although there's some ebbs and tides in the market as we're able to charge those vehicles as we travel around our spaces in which we live in, and affordability is going to change and all those kind of things. That market is not going to stop. It's going to keep moving. So it's estimated that by 2030, over 1 in 4 new passenger cars is going to be an electric vehicle. So the auto industry's transition to EVs is accelerating. And we know that because we deal with some of the manufacturers on a daily basis and the people that are uh, creating and developing new vehicles. They call us to help with protection as well. That statistic came from S&P Global. Original equipment manufacturers, when you see the word OEMs, I know some of you around the world may not be familiar with that acronym, but it stands for original equipment manufacturers. So we're talking about the people that make the vehicles, no matter if it's some of the bigger car companies and truck companies that you heard of, or the ones that make things like lawnmowers and construction equipment and mining equipment, ag equipment. Those are all OEMs. We have outfitters and upfitters, integrators, dealerships, repair shops, all the way through the life cycle of the vehicle, and then to the recyclers. Pretty much everybody along that line is catching up with the technology and the hazards that are involved with electric vehicles, as well as some of the other materials. So what we're here to do today is to build on that awareness and hopefully show you how rapidly fires can develop in some of the new technologies. So this is a little bit of a graph of the market through 2023 and electric car sales in the different countries like China, the European continent, the United States, and others. As you can see, it's going up and up. And although there are ebbs and tides in that market, and it'll speed up and it'll slow down, it'll speed up and it'll slow down. It's not going to stop really in the EV market for decades and decades, most likely, as long as the material side can keep up and the supply side. And that's because of a global push, global initiative by government and so forth to look for alternative fuels to stave off climate change. So one of the big areas of concern that we're dealing with is parking garages. The parking garages are frequently attached to vital infrastructure, things like hotels, hospitals, airports, large buildings. They're increasingly threatened by incidents that involve electric and hybrid vehicles. And because of that, there has been a change in NFPA 13, for example. The standard for installation of sprinkler systems has changed to increase the recommended hazard classification for parking structures from an ordinary hazard group 1. Excuse me, I gotta make an adjustment on my screen here. From an ordinary hazard group 1 to an ordinary hazard group 2. And that, in effect, is a 33% increase in the design density, moving from a 0.15 GPM per square foot to a 0.2 GPM per square foot. And then FM Global as well has changed their data sheets to increase the hazard category for parking garages and car parks from a hazard category 2 to a hazard category 3. So not only is the standards making industry dealing with that increased threat to parking structures, the insurance companies are as well. They're taking notice. And then we're trying to make firefighters around the world more aware of that threat. A lot of them have seen it. Other ones are blissfully unaware, but there are many, many parking garages that are unprotected by sprinklers. The new 2023 edition of NFPA 88A says that all parking garages are now required to have sprinkler systems installed in accordance with NFPA 13. However, your locality will have to have adopted that latest edition of NFPA 88A to recognize that. So there are many localities that won't have adopted that. And there are many localities around the world that are on another system. Some of them are ahead of NFPA, some of them are behind. It just depends on where you fall in that spectrum and how your locality is dealing with that. Charging stations are popping up all over the place in parking lots, supermarkets, shopping centers, business parks. But here in the US, at least, other than electrical codes, few other standards address the location of chargers, how far they are away from other exposures, where they can and can't be located, or specifying other adequate fire protection for the vehicles parked there, how far apart they may be placed. Um, again, where they're located in respect to other exposures. So these are all things that the standards making industry is just starting to become enlightened to and sit down and talk about and begin to design new codes around. So really the automotive industry is way ahead of the standard making industry, which is a concern in many ways, but it's just the nature of rapid development. Cities and countries are rapidly adopting mass transit powered by electric powered buses, trains, trolleys, all kinds of things. Fleet vehicles, government and businesses are adopting EV fleet strategies. So school buses, for example, a lot of localities are buying into fleet EV school buses. So that's a new thing. Route companies, delivery companies, utility companies are buying fleet EV vehicles to replace their internal combustion engine powered vehicles. So all of those organizations and markets are going to need to be educated as well as brought up to speed on how to deal with and prevent fires and prevent putting themselves in bad situations where they may be just parking or using their vehicles in ways that they probably shouldn't to avoid problems. Fleet charging facilities, for example, you may have many buses lined up right next to each other charging, and if one little cell goes bad, it can take out not only a single bus or truck or fleet EV vehicle, but it can take out a whole row of them. And that can be very, very hard to stop once they get going. And they can be indoor or outdoor. The indoor ones present an additional challenge, especially with low state of charge batteries. They tend to put off more gases than a high state of charge battery before they go into flaming combustion. So in those cases, you can have a buildup of those flammable gases and it become absolutely explosive in that indoor atmosphere, which is something that a closed standard sprinkler system, it doesn't see gases, so it can't suppress that. So it's something we need to work on the detection side of fire protection systems as well. So these situations can become mass fire and explosion hazards, and we just all need to work on raising our own awareness of those situations every day as we look around us, looking at situations where vehicle incidents have occurred in the past. That's where they're going to occur in the future, but with a different type of fuel, different type of directed energy that can really create some challenges. Specialty vehicle, heavy equipment industries are working hard to develop industrial strength EVs. So construction equipment, agricultural equipment, mining equipment, material handling equipment, indoors in warehouses and distribution centers. A lot of that's going to lithium-ion battery power. So EVs are literally everywhere, and that market is growing. But again, we're not here only to talk about EVs. We're going to talk about vehicle construction, leaks, all the traditional stuff, as well as some of the new materials in the volume of those materials as they're taking over the automotive industry. So who needs to know this? So again, those are original equipment manufacturers, the upfitters, the technology integrators, the the companies that take cab and chassis trucks and put their rear end on the truck, their cargo box, their flatbeds, their garbage trucks, etc., that go on the back of the cab and chassis. They need to know the hazards of dealing with electric vehicles and other fuels as well as they develop on those chassis. Dealers and shippers have had a big problem in the last couple of years with electric vehicles, especially in ships where electric vehicles are being transported more or less door to door, and in enclosed spaces. It can take out an entire vessel and really provide a big source of harm to the people that are working on that vessel, as well as firefighters too. Dealerships, they get not only new vehicles in, but they have to repair them. First and second responders, so first responders are thinking about the firefighters and the police officers, of course, but second responders, the tow and recovery operators, fire investigators, people that show up secondarily to the same incidents, they all need to be aware of the hazards that they're dealing with. Technicians that work on the vehicles, our municipal leadership and our legislators need to be aware of the hazards as we're bringing forth new codes for them to adopt and why they need to adopt them. Yeah, and we can't just take on this new technology without new codes to go with them. Code enforcement themselves, they need to be able to recognize the situations and apply codes to those and understand when, hey, there might be new technology to deal with this code that falls outside of traditional lines. Maybe the traditional code doesn't address it well enough. Environmental experts, of course, fire suppression industry in general, sprinkler companies, sprinkler contractors, designers, fire protection engineers need to raise their own awareness of many of the materials being used, as well as lithium-ion batteries and how to suppress those. Property owners and managers, somebody owns those fleet facilities, somebody owns those parking garages and structures and apartment buildings. Users and fleet users, so get out on the road and have a road hazard or a crash. They know how to respond to that appropriately, or at least when to run away. And then the end of life for the vehicles to recyclers. They're seeing an issue as well with figuring out how to recycle these vehicles with some of the new materials in them, as well as the electric vehicles. There's no one set way to de-energize an electric vehicle's battery prior to removal. And one of the problems is the vehicle may not come in intact. It may be wrecked in some manner. So at the end of the day, we do want you to go hold of us, and you see the contact information down there. We are a global distribution company, and we can serve you no matter where you're located. And we do want you to get a hold of us in the end. And I'm throwing this up now to put that thought in your mind to reach out to us. But we'll put that up again at the end as well. We'll move on to our second section here. Again, I'll remind you to make sure to write down your question so you don't forget it by the end. We want to see it in the chat so we can address it. So let's break down the automotive hazards a little bit, one by one. Look at the modern day combustibles, not only lithium-ion batteries, but firefighters respond to collisions, vehicle fires, and more. There's a lot of materials that create unique risks and a lot of situations that create unique risks. And firefighters don't get a choice of what they get to respond to or not. They have to go to every call and then figure out how to deal with it best once they get there. So this next little video is going to show you what we call a three-dimensional fire. I can get it to play.
Dan, can you down the sound to listen you?
Is that better? Can you repeat that, Hernan?
Yeah, please. Can you decrease the sound to listen you? Because the sound of the video is very loud.
Okay, I will try. Oh, I see that.
Yeah.
How's that?
Now,
Better? Okay. Those darn sirens. So we have what we call a three-dimensional fire. So we have a liquid ignitable that's flowing, coming out of the tanks. We also have three-dimensional object in the middle of our pool of fire that is making the fire cascade down it. It would make it very difficult for a phone rocket to work in this case. So right now they're using plain water to try to keep the flames back away from their own hoses, and that's with limited success. And it keeps following them around as the flowing liquid seeks a lower space. They're having to deal with that. So this is just one of the challenges to deal with that our product can really help firefighters keep moving. Not only dealing with the fire and the fuel tanks, also very hot objects. So the entire engine block on this truck holds an immense amount of heat. So the cooling streams are very important to that, as well as the cargo. The cargo can be a challenge in itself. So some of the modern materials that we're dealing with, not only the petrochemical fuels, but lithium-ion batteries, hydrogen gas, compressed natural gas, a mixture of fuels in the same vehicle in some cases, hydraulic energy, if we're dealing with construction equipment, ag equipment, or anything like that, even the recycling trucks or the trash trucks have a lot of hydraulics associated with them, a lot of specialty trucks out there. Aluminum, high strength and ultra high strength steel, boron, magnesium, so those combustible metals, carbon fibers and plastics, fiberglass, synthetics, rubber tires have always been a challenge, and they still are. Those are classes A and D as far as the fire class goes. Stored electrical energy in the battery electric vehicles, the hybrid electric vehicles, and the fuel cell electric vehicles are actually going to be utilize battery storage as well. So all of those are going to have stored electrical energy as a challenge as we deal with them either in the automotive industry or as firefighters. High pressure devices and explosive devices in your safety restraint systems. And then the vehicle superstructures themselves from hydroformed, extruded materials, strengthened cast materials. They can cause a difficulty in extricating or rescuing patients and also result in Class D metals fires. So a lot of different materials there we're dealing with all at the same time. It's not one material causing the problem. It's not just lithium-ion batteries causing the problem. It's not just combustible metals causing the problem. It's the fact that they're all thrown in together into the same incident. So we have all of these different automotive fire fuel classes, Class A's, Class B's, the three-dimensional Class B, and all of those create a mix of explosive vapors as a hazard as well. Class C, energized electrical equipment, Class D metals, and then lithium-ion batteries, which at least here in the U.S. fall outside of a fire class. And again, these are all at once hazards. So we look at each one of these hazard classes. The Class A's, again, when we're talking about vehicles, we're talking about tires, the solid synthetics, insulation, carpeting, belts and hoses, things of that nature. Class B's are the liquid ignitables, and the gas is ignitables as well. So if you have a natural gas powered vehicle, that's considered as Class B as well. And then one of the challenges with those is we're dealing with a lot of ethanol-based fuels nowadays, because they're removing PFAS from foam. It makes it more difficult to deal with. So a lot of the fluorine-free foam products don't perform as well on the polar solvents, especially. They don't seal as well around structure, and they don't put out three-dimensional fire for the most part as well. Some do, some don't. It just depends on the formulation. In any case, you have to apply a lot more than you used to, and the performance has been somewhat degraded without the PFAS in there. PFAS was added on purpose because it worked well. Class C, energized electrical circuit. When we're dealing with electric vehicles or vehicles that are plugged into a circuit for charging, we're dealing with that energized electrical equipment. It's not a huge hazard, but it is a hazard, and we need to be aware of that. And one of the things that hazard can cause is, number one, electrical shock to people who are working around it, but it can also cause an accidental short circuit, which results in thermal runaway very, very quickly, just because maybe you dropped a tool. So have to be careful around them not to complete a circuit. And then the Class D, your metals hazards, all the new exotic metals in some of these vehicles to make them stronger, stiffer, more lightweight. It's very important that we're ready to deal with those kinds of fires and scenarios as well. And again, one of the big challenges is we're not dealing with one of these classes at a time. We're dealing with them all at once, all in the same vehicle or in the same crash. So you have your combustible spills, leaks, and vapors like we've always had. We've always had hazardous runoff that we've been dealing with. We're going to talk about a better way to deal with that today. Three-dimensional fire has always been a feature of vehicle fires. Again, we're going to talk about a little bit better way to deal with that today. Explosive toxic gases and smoke production. Although that's a feature of almost any vehicle fire, with electric vehicles in a low state of charge, especially, you can have a lot of explosive and toxic gas production prior to flaming combustion. So what that leads is to an explosive atmosphere that a firefighter could walk into unknowingly, or if it occurs in one of your production facilities or an automotive dealership overnight, or when it's not being closely monitored, it can result in an explosive situation that someone could accidentally walk in on, or the structure could just explode without warning if it's not being occupied. And nobody wants that to happen, because it interrupt the continuity of your business and threaten your people, your facility, your business processes, and your industry. High intensity jetting flames, that can occur because of compressed gaseous fuels, but it also occurs in the case of lithium-ion batteries. And it's a characteristic of lithium-ion battery fires that provides somewhat of an extra point of danger, especially to nearby exposures. It catches them on fire very, very quickly and can result in collapse of the structure. Metal fires, as you know, burn at such a high rate that they are water reactive, and a high temperature. The high temperature of metals fires up around 5,000 degrees causes the hydrogen and the oxygen atom to split and become raw hydrogen and raw oxygen, and then that enhances the fire very, very rapidly, and at the point where it's reactive, comes back on the nozzle of the firefighter and results in potential burn injuries. And then material ejection and shrapnel hazards. There's always been some of those things in vehicles, but as we move more towards electric vehicles, that possibility of material ejection and shrapnel is much higher. So not only can that injure people, but it can cause fire to travel from an involved area of a structure to an uninvolved area when objects on fire fly from one area to another. So we look at vehicle incidents now, we have to look at them differently overall. We have to look at them as kind of a totally new entity. But the way I like to put it is we don't want to just focus on the specialty of electric vehicles. We have to reform our thinking about approaching every vehicle. So when I say EV, I kind of refer to every vehicle. We have to approach them all differently from now forward. The situational automotive hazards that we're dealing with, not only we're looking at materials and fire threats and this and that, but a lot of the processes that we do and we're used to on a day in and day out basis, because we're used to the hazards of internal combustion vehicles, are changing. So during the manufacture, shipping, dealership, and repair shop mode of the vehicle's life cycle, things are changing because of the modern materials, the way things are built in electric vehicles. So I have to take a new look at that, redo how some of those processes are carried out, and then as well take a fresh look at what type of manual fire suppression we're providing to the employees and what kind of automatic fire protection we're building into our facilities. And that threat is more intense now than ever. These fires are fast growing, rapidly developing fires that can take down your building or facility very, very quickly. We look at the life cycle of a vehicle. When we're talking about EVs, especially, we globally don't know the impacts of aging batteries yet, by and large, because most of the vehicles that are on the road are not very old yet. There are some that are out there, probably reaching the 8 to 10 years old lifespan, where some of the battery cells are going bad, and there are some repair shops out there. There's one repair shop in Arizona, for example, that they're on their third facility because it's burnt down twice because of working on vehicles that were in some state of disrepair. And then the recycling, of course, at the end of the life cycle of the vehicle. How are the batteries being recycled? The whole recycling industry needs to take a fresh look at fire protection from start to finish. Many people have talked about tacking on some kind of an assessment or a tax to the battery manufacturers and the automotive manufacturers to help deal with the additional threat to the recycling industry and the benefits that it brings to society. So we'll see where that comes out. But there is an added fire threat in the recycling industry because of lithium-ion batteries, plus the traditional threats like tires, combustible metals. That side of the industry will grow as well. And then just processing and storage hazards along the way for all of the different raw materials anywhere in the life cycle of manufacturing and recycling, as we have a circular economy. So people are threatened by this new technology. Property infrastructure are threatened. The supply chain is threatened at some point. If you look at the large vessels, ships that have burnt because of these issues, that's a threat to the supply chain, railroad, trucking, etc. Environment is somewhat threatened, although typically on a smaller scale and I would say an acute scale per incident. Responders are threatened, industries are threatened, as well as their business, and then public health in general, by especially when a recycling center or something like that goes up, you've got a lot of smoke and other byproducts generated. Some of the pictures here, you'll see a parking structure that's on fire. The one in the bottom in the center was one in Norway that collapsed due to an EV fire. So let's look at some solutions here. So Hazard Control Technologies manufactures F500 encapsulator agent. It's one water additive agent. It works in all applications. You'll hear me use the term broad spectrum because it's a broad spectrum agent. It helps deal with all sides of the hazard, which is really great. There's a lot of solutions out there that deal with one part of a hazard or another, one aspect of fire or another, but F500 really addresses all aspects of the hazards associated with vehicle fires and automotive industry-based fires and spills and so forth. So we're talking about NFPA 18A. NFPA 18A is a standard that in 2022 was updated to include more clear language about encapsulator agents. So NFPA 18A is the standard on water additives for fire control and vapor mitigation. So an encapsulator agent is a water additive agent whose basic building block is a spherical micelle. Spherical micelle is capable of encapsulating carbon and hydrocarbon molecules that are both polar and nonpolar liquids. So helps separate the fuel or isolate the fuel from the oxygen on a molecular level. But it has a lot of other benefits as well. So encapsulator agents are a fluorine-free, non-corrosive, biodegradable agent. There are no RCRA reportable chemicals in it. It's F500 is multi-class, UL listed in Canada and the US as NFPA compliant fire prevention, protection, and suppression. It's a combustible, inflammable vapor and liquid spill mitigation agent. So again, it deals with all sides of the hazard on a broad spectrum.
Encapsulator technology, the next generation of fire and hazard mitigation. First, we start with a simplified version of a single encapsulator agent molecule consisting of a hydrophilic polar head which loves water, dissolves in water, encapsulator and technology, a hydrophobic non-polar tail which the next generation of fire and hazard mitigation. From water.
Let me start that one over. I did not take off right.
Encapsulator technology, the next generation of fire and hazard mitigation. First, we start with a simplified version of a single encapsulator agent molecule consisting of a hydrophilic polar head which loves water, dissolves in water, and a hydrophobic non-polar tail which fears water and will do anything to get away from water. Once the EA molecules enter the water, they instantaneously and automatically orient with the nonpolar tails inward and the polar heads outward, forming millions of spherical micelles. Micelles travel towards and exit the nozzles, forming EA droplets. Micelles nearest to the surface of each droplet automatically break apart. The nonpolar tails orient outside the droplet with polar heads on the surface, forming an EA skin on the surface of every droplet. In addition to the EA skin, there are millions of molecular spherical micelles within each droplet.
So if we look at that breakdown of the water droplet there, you'll see the blue part. That is the outer surface of the water droplet. On that surface, we have a coating of the polar heads of the F500 molecules. And then we have the tails all sticking out of the F500 molecules, helping to gather more carbons, hydrocarbons, and absorb heat. Inside of the water droplet, it is stuffed, it is packed with spherical micelles. Those spherical micelles are where the trapped carbons and hydrocarbons reside, isolated from oxygen. when they're isolated from oxygen, they cannot combust. So as this water droplet is flying through the air, the nice thing about the F500 as well is it breaks down the surface tension of the water. So it allows the water droplets to be much more smaller and uniform in size. You don't have big blobs and little blobs. You have a bunch of very, very tiny droplets. And those tiny droplets absorb a lot of heat as they pass through the air. And they also encapsulate gases as they fly towards the fire. And so it's dealing with that part of the fire as the whether it's a mist or a fog is flying towards the fire, it's encapsulating gases on its way there and cooling those gases as well. And then when it actually strikes the fire, depending on what kind of state of matter the fuel's in, it interacts with the fuel directly. So if it's a liquid fuel, it's going to mix with it. And if it mixes with those carbons and hydrocarbons, it gathers them up, it encapsulates them, and it inerts them, as well as it cools them, cools that liquid below its auto ignition temperature, and stops the combustion process, that chain reaction. If it's a solid but porous material, it soaks in, it wets very well, and it cools, and it prevents reheating and reignition. And if it's just a really solid material, more like a steel or hard rubber, it cools that surface very, very effectively. And due to the high molecular weight, it's very persistent. It doesn't just bounce off and beat up like a water droplet would. It stays there, absorbs heat until it vaporizes. And it vaporizes very uniformly, it absorbs heat very uniformly in a fraction of a second, and really cools much more efficiently than plain water. So although it's only mixed at somewhere between 0.5% and 3%, and so you've got 97 to 99.5% water, it makes that water much more effective.
Encapsulator technology.
So some of the properties, number one, between some of the differences, I should say, between a wetting agent, which falls under NFPA 18, and an encapsulator, which falls under NFPA 18A, is that an NFPA 18A encapsulator agent actually does the encapsulation with the spherical micelles and isolates it, neutralizes the fuel, whether it's a gaseous fuel or a liquid fuel. Has much more rapid and uniform heat reduction because of the fact that it's packed with those spherical micelles. It absorbs heat much more readily. It's not just breaking down the surface tension. Free radical interruption. We'll talk about that in a minute or two, but free radical interruption is another thing that encapsulator agents do that wetting agents don't, but they both break down the surface tension. I'll show you the difference here a little bit. Encapsulation, it's one of the superpowers of an encapsulator agent. It helps it mitigate a lot of different types of hazards, not only from a fire perspective, but also from a hazardous materials perspective and carcinogen reduction perspective. The elimination of flammability provides stable long-term burn back resistance. Those spherical micelles are stable even in the presence of super high heat, such as direct flame contact. It doesn't cause them to break down. So it stays encapsulated, it stays neutralized. Cleanup is simplified, and we'll talk about that in a little bit and why cleanup is simplified. Let's talk about spherical micelle encapsulation. And this is a spherical micelle encapsulation test as the NFPA uses. This one's a little more simplified for the ability of people to understand what's going on and the overall effects of it, but that's what we're doing. We're doing a liquid encapsulation. We've got a gallon of fuel there. that
Please,
parts of fuel, we're adding about
can you down the sound, please?
to that 8 parts of fuel, we're adding 1 part of F500 and then about 40 parts water. And we're agitating it in, causing that encapsulation to kinetic energy, causing it to readily mix with the fuel. Although it's white, we're not trying to create a foam blanket. Again, we're trying to mix it with the fuel and inert the fuel in its entirety in this case. But if you have a larger tank, you really only need to encapsulate and cool the surface to put it out. We've got the burning tires back there. Been burning for a while. They're pretty hot. We'll let them burn a little bit more of this. First test he's going to do is a direct flame test on the encapsulated fuel, and to make sure it won't light. And that's because all those hydrocarbons that were in that fuel are trapped inside of those spherical micelles. Got the direct flame going on there with no ignition. Now he's going to take some of that encapsulated liquid, which is now an inert waste product, you can see how quickly it extinguished those tires. And it also took the smoke away very, very quickly. That's the free radical interaction. I'll talk a little bit more about that free radical interaction in just a minute. But this shows that once the encapsulation is complete, we've got an inert liquid here that is not flammable. That's the difference between an encapsulator agent and a foam, is we're not creating a blanket on top of it. We are actually changing the product. Rapid heat reduction. So rapid heat reduction is the second superpower of F500. It results in improved knockdown capabilities. If you've ever battled a hot object inside of a pool of liquid with foam, you'll know that's one of the biggest challenges, to get that hot object to cool down so that the foam can form a blanket around it and finally put it out and stop it from burning back all the time. With F500, it cools those objects much more quickly and effectively. Effective droplet utilization, the high molecular weight, that persistent contact with the material cause it to cool down much more effectively. It absorbs that heat readily and more uniformly into those smaller water droplets, and results in vapor production, but not steam production, no scalding steam. And then one of the other benefits of rapid heat reduction is the saving of time, resources, and energy on scene. So this is a test at Fraunhofer HHI Institute in Germany. This is a lithium-ion battery, a single truck battery module, and it's put into thermal runaway by some glow plugs. And then once it goes into thermal runaway, we're going to show you that one of the benefits of F500 is the rapid heat reduction, the ability to soak in and cool. So we've got batteries going into thermal runaway. You're going to see the heat on the graph climb. And then once the F500 goes on to the batteries, see that heat drop very quickly, go back down to ambient temperature. And stay there. So that happened in less than 10 seconds. It went from a high heat condition, probably more like 5 or 6 seconds, from a very high heat condition back down to ambient temperature and stay there, because it soaks in any battery modules or battery cells that would have been damaged. The F500 soaks into them, interacts directly with the flammable electrolytes, and inerts the electrolytes as well. So free radical interruption, which we've mentioned a couple of times, that really it takes that smoke away. But if we think about what's in smoke and what we teach firefighters, what's in smoke? Smoke is buoyant fuel. It's carbons and hydrocarbons resulting from incomplete combustion, and incomplete combustion creates an imbalanced electron situation in the atoms that come off of the fuel and off of the fire, and those free radicals are seeking balance. So they made up with other free radicals and create new compounds in the air that result in smoke and soot. And carbon monoxide, hydrogen cyanide, hydrogen fluoride, lots of benzenes and derivatives of benzene are created in that process depending on the fuel. So that smoke, what it does typically, if it's in a compartment, it carries your fire forward. It creates a flammable atmosphere. It helps the fire grow in size, roll over in that atmosphere, flash over, and carry forward. So if we can reduce the production of that smoke in the first place, that's a big benefit to putting that fire out. The other thing that smoke does when it comes to first responders is it causes you cancer. As it accumulates on your turnout gear and you get it on your skin and absorbs into you, it causes cancer, and we know that. So anytime we can reduce the production of those compounds in the atmosphere, we're doing everyone a good service. So free radical interruption does that. Again, it's due to the high molecular weight of the product, but I'm going to show you how it works in this video. I'll watch the volume from the beginning this time. So you see a pile of tires on fire again, and watch the smoke. We want you to really pay attention to the smoke as he's applying the F500. How the smoke changes to a white vapor. The white vapor is simply the F500 vapor absorbing heat. But the smoke is gone almost instantaneously because we've interrupted the coalescence of the free radicals. They're not able to come back together and form new compounds. If you've ever fought a tire fire, you'll know plain water won't put them out that quickly, nor will it control the smoke. So the fourth superpower or benefit of F500 is it's environmentally friendly. So the health and safety, not only small fires like the one we just saw, but think about a recycling facility or a large business, a chemical company that's on fire, and the plume of smoke that comes off of that. All of that smoke goes somewhere. It all settles on something. It all settles on cars, door handles, playground equipment, lawns, dairy pastures, you name it. It's settling on something that everybody ends up becoming involved with at some point. So it's kind of a listing here of those in a summary of those superpowers again: the encapsulation, the rapid heat reduction, the free radical interruption, and the environmentally friendliness. With plain water or foam, you don't get that environmental friendly outcome. Plain water dilutes products, but just washes them away in their native form. And then foam just adds to contamination. With an encapsulator agent, we're actually encapsulating carbon and hydrocarbon contamination as it's applied. Plus the fact that you use a lot less, you create a lot less runoff. So, broad spectrum impact. Look at, since it's a water-based agent taking advantage of in-place engineering when we're talking about facility protection. Fire response tactics as we're using them now, just with a water additive rather than plain water. Spill procedures, a little bit of a change there, but we're changing how you would approach certain spills so that you're not having such a hazardous outcome from some of those spills. And we do that by interacting with materials on a broad spectrum basis. So first off is flammability. We're reducing the flammability of whatever's on fire, especially when they're liquids or gases, and we're inerting those items. We're reducing the explosivity by encapsulating gases out of the atmosphere as it's applied. So again, it's a broad spectrum, and if we can take lithium-ion batteries, for example, if we can catch them during the phase when they're off-gassing prior to them going into flaming combustion, we can eliminate the explosivity as well as tackle the thermal runaway. Toxicity, we're knocking down that toxicity in the atmosphere no matter what kind of fire we're dealing with. And we're reducing heat. And when we reduce heat, we're stopping that chain reaction. We're stopping that heat flux of going back into the material and causing more and more ignition. And then we're reducing contamination. We're not just pushing contamination around. We're not forcing hazardous vapors from one space into another like you would with water, where you can move vapors around. We're actually absorbing and reducing those both flammable and toxic vapors as it's applied. And that results in less time on scene, less water used, results in less runoff, and it results in complete extinguishment, not just fire control. Automotive applications. This is why you showed up, right? So we're looking at automotive applications of encapsulator agents, and here's where we benefit you in the automotive industry. So molecular mitigation of your problems, rapid heat reduction, excellent penetration, significant toxin reduction. When you're dealing with foam, as I mentioned, we're not dealing with altering the base chemical at all. We're just putting a blanket on top of it and adding contamination, because foam itself in many cases has contaminants in it. If it's PFAS, and even some of the non-PFAS ones have other agents in them that are carcinogens or are harmful to people. And they don't reduce heat well, and they don't reduce toxins in the atmosphere. And plain water is mechanical mitigation. It cools, just not as effectively as F500. F500, as you can see by the chart over there, cools at least 4 times more effectively than plain water. So if you look at an amount used to absorb 6.6 million kilocalories of heat, you're looking at using 250 gallons of water versus 1,000 when you're talking putting F500 with it at 1% solution. And that's on a Class A material. Water, inefficient heat reduction. Some of it absorbs heat, the rest of it runs off. Minimal toxin reduction. It can push them around, it can dilute them, but it doesn't absorb them or encapsulate them like an encapsulator agent does. Lithium-ion batteries, we've got 15 years of proven performance with lithium-ion batteries, and how it not only controls them, puts them out, and puts them out permanently. So good performance there. Third-party protection, proven protection with lithium-ion batteries. I'm going to show you one more video that from that same institute. This time we've got 10 of those truck batteries lined up. So this is 10 times the kilowatt hours we had in the previous fire. And Our agent application is largely based on kilowatt hours. That's where we base our rate of application and quantities on when we're talking about how to protect a facility and or how to manually attack something, based on flow, kilowatt hours, gallons per minute per square foot. Getting thermal runaway here. We're letting it get going pretty good. So there's no doubt it's well involved in the thermal runaway and all the individual 18650 cells that are making up the truck battery. The agent's going to kick on here in a second and put this fire out permanently with no reignition. And it's out. Again, no reignition. And that's the way it typically goes. We do recommend that firefighters wear SCBA at all times when they're dealing with lithium-ion batteries, and that's one concern in a factory environment or something like that with workers using handheld fire extinguishing equipment, is that their respiratory protection.
This is a lithium-ion battery test provided at the request of an international car manufacturer. Speed of extinguishment was the primary requirement, and secondary was cooling. The
The amount of
have been overcharged
off-gassing that
to the
takes
point
place
where they
before
ignite.
flaming combustion.
From initial conflagration, the temperature is around 400 degrees Celsius. When the explosion happens, the temperature has more than doubled to over 800 degrees Celsius.
One of the characteristics of the lithium-ion batteries is that you're going to have that cyclical nature to the jetting flame. So right now, some
In
more
order to understand
cells
what would
are
happen
getting into
after
thermal
the initial
runaway, and you'll have
explosion,
more
the
jetting
batteries were
flame.
allowed to burn for a
And,
further 5 minutes.
That jetting flames will cease again as that individual cell or two or three runs out of electrolyte and gets into the next cells.
From the moment F500 is applied to the fire, the flames are out within 3 to 4 seconds.
And you have the cylindrical cell type of lithium-ion batteries. Each cylinder or each cell is more or less going into a state of levy
The
or boiling
temperature very
liquid
quickly
expanding
drops
vapor
down
explosion,
from over 400
off
degrees
gassing
Celsius.
with jetting flames,
I was
and then running
recording
out of
at
fuel.
300, 200, 100 degrees Celsius, and within 3 minutes of the application of F500 was recorded at 40 degrees Celsius. And a further minute after that, the batteries were able to be handled.
So although there's not a standard here in the US, there's a Dutch standard, and it's an international standard as well. It's recognized internationally. And NFPA 18A Annex 4.3 now mentions encapsulator agents specifically, and talks about the third-party testing over many years, which we have been involved with, as well as there's a lot of it's taking place independently, like the ones we just watched without our involvement. The Dutch standard is called NEN-NTA 8133, and that's for small items personal electronics such as smartphones, laptops, drones, small appliances with batteries up to 600 watt hours. F500 passed the NTA 8133 and is third-party tested on lithium-ion batteries up to 3,400 watt hours, far exceeding that NTA 8133 norm. So you want to know more about that, we can certainly get you more information on that as well. Class B, talking about all your liquid ignitables, spills, spill fires, things like that. And we're UL listed in the US and Canada under Class B. We have molecular mitigation. It's PFAS free. We don't create a foam blanket. We actually inert the flammable liquid, especially if it's in a spill or a small tank, and then put the fire out permanently that way. So tires, recyclables, things of that nature. Been dealing with that for decades. F500 has been the product that agencies have called for when they cannot get a tire fire to go out all around the world for decades. This one takes place in Cerro Patagon. One of the things we want you to take a look at here is the use of resources. So we took a total of 18 pails and 90 gallons of F500 to put this fire out. It had been burning for days. We look at water, plain water, which they had been applying for 42 hours prior to F500 showing up. Compared to the 2 hours once F500 got there, you get a difference of 40 hours. That's a big resource difference. Wear and tear on your personnel and your equipment. Oops. I messed that up. So personnel hours, with water, they already had 420 hours invested. Once F500 was on the scene, they invested 10 hours. So a difference of 410 man hours or staff hours. Wear and tear on your vehicles and your equipment. With plain water, 2 fire trucks were involved for 40 plus hours. Once F500 there is 1 fire truck for that same period of time, just a couple hours. With plain water, 10 firefighters. Once F500 was there, 2 firefighters got the job done in a couple of hours. So a difference of 8 firefighters involvement that lets you free up staff and resources to move on to other fires more quickly. And we don't only see this with tire fires, we see it in every class of fire. The availability of resources is important. Wear and tear on resources is important. The more time you spend on scene, the more risk there is, the more cancer exposure there is, the more risk there is to getting struck by a vehicle if you're on the roadway. Anytime we can reduce that, we're benefiting everyone. And reducing the loss. Machine hours, 82 hours less with F500. Where we get our figures for the heat absorption, 6.6 million kilocalories with plain water, 63.3 million in the same time period with 1% F500. Water consumption is important because of many factors, especially clean, drinkable, potable water is sometimes at a premium. So when we can use less water and put out more fire, everyone is better off.
Dan,
Yes.
a detail about this fire, that this fire was on 2021. This is part of a big landfill that they throw tires, and they have this kind of fire before. This is why they have all these numbers. And the difference on the smoke, the black smoke, and the firefighters start to have problem with the neighborhood close of the landfill. This is why they start to use this product, and they extinguish the fire faster than with water and foam. But this year, this landfill start to be on fire for 6 days, and they try to extinguish with water. And the day 6, they call to our company and they start to use the fire, and they extinguish the fire in 4 hours. Yeah. This is why in this moment, in this facility, when a fire department receive the phone call, they send the fire truck with the product immediately. And they
Right.
only spend 2 hours when they start to combat the fire.
Right.
It's like a detail that the firefighters are dealing every year, because the people close of this landfill burn these tires of the landfill.
So the impacts aren't only to the fire department, the impacts aren't only to the facility, the impacts are to the whole community.
Yeah, you can listen the communication of the fire department and say, please send me 1 truck plus A500 all the time in the radio.
Right. And then the resources are available to the rest of the community as well, much sooner. And then we look at spill control in the automotive world, whether you're a firefighter or you're working in a repair shop or some other part of the automotive world, spill control is very important. So an encapsulator agent can be sprayed on most hydrocarbon spills as a surface washing agent. It's EPA listed surface washing agent. It'll inert that product, make it non-flammable first off, and then in many cases it can be flushed off into the soil, and the microbes will take care of it from there. There are certain instances where that's not advisable, but they're few and far between. And in most cases, a day or two later, you're now not able to find evidence of the spill because the microbial action has taken care of it. It's actually healthy for the microbes in the soil if you encapsulate it with the proper quantity of F500. So we're getting close to the end here. I know we're getting a little bit long, but we're going to talk a little bit about suppression systems that we have available. So HCT recommends, of course, that you have manual firefighting suppression equipment available for employee use to keep small fires small spills taken care of right away. I'll give you an example. Dry chemical comparison. If you've ever used a dry chemical fire extinguisher to try to put out an engine fire or something like that, they always come up short. They always run out of material right as you're knocking the fire down, and you think you got it beat, and then it runs out, and that stored heat, and whether it's a big tire or an engine block, something like that, it comes roaring back and you're out of material. Well, two dry chemical extinguishers failed to put out an engine fire on an old truck in a dairy barn in Texas earlier this year. And because they failed, 18,000 dairy cattle died in one fire because they didn't have the right suppression equipment there. So our fire extinguishers work very well at not only knocking down fire, inerting fuel if you have a fuel leak, but it also cools very, very well and puts fires out much, much better than dry chemical. So we have fire extinguishers, TKO nozzles, we call them. They're a nozzle with the agent bottle right attached to the nozzle. Undercar and piercing nozzles, mobile carts for standpipe use, agent trailers and skid units for municipal parking garage and factory protection. And we're working on engineering in several aspects, but one of those is onboard suppression systems for vehicles. Our bladder tank systems, which we've been on the market with for years, are used in a lot of machinery and equipment areas, conveyors, things of that nature to protect specific types of machinery, equipment, or areas, transformers, things of that nature. And then our water-driven proportioners are kind of our one of our newest feature pieces of equipment. The nice thing about a water-driven proportioner is its wide range of performance. The fact that it just uses an atmospheric tank to store your liquid, and then the water-driven proportioner is placed right into existing risers or new risers if it's new construction to meet the need of the max flow of the product. And doesn't only work with F500, it'll work with other products as well. So kind of how it works. The big red tank there is your storage of your concentrate. As water flows through the riser, it spins the water motor. And then the agent is proportioned into the line with either a piston or a rotary gear pump to meet the flow. It's a very simple device. It's easy to test, easy to maintain. You don't have the waste material, and you don't have to refill a pressurized bladder tank, which can be costly and tricky. So it's a very robust device, can fit almost any need or size of riser, makes testing easy, very popular item. Portioning rates can be whatever you need for your facility or situation. Wide range of viscosities as well, from motor oil to honey, and anywhere in between. You know what I'm talking about. So your next task, get a hold of HCT. Questions?
Yeah.
Okay, thank you. Okay, Dan. Thank you so much.
Thank you, everyone. Really
for
appreciate your
the
participation.
video.
Thank you. Thank you, Bob.
You can say goodbye to everybody.
Bye-bye.
Okay, bye-bye.
Thank you, everybody. Have a great day and a great week.
Thank you.